Hi all. Let's see the next topic of input output organization, which is direct memory access or DMA. Coming to the contents, in today's lecture we are going to discuss about introduction to what is direct memory access and what is the role of a DMA controller in a direct memory access and the working of a DMA controller, what are the different types of data transfer modes and the advantages of DMA as well as its disadvantages. So coming to the introduction, direct memory access or DMA, it is nothing but the feature of a computer system that enables the data transfer between the peripheral devices and the memory unit of a computer directly without the intervention of the CPU. So, if you consider the previous lectures where we have discussed about different types of approaches like polling mechanism, interrupt initiated IO, where you come across a daisy chaining mechanism and priority interrupt. So, in those cases, whenever an information has to be transferred between IO devices or a peripheral devices and the memory unit of a computer, it is done with the intervention of the CPU, where the CPU takes a whole and sole responsibility of the data transfer. But in case of a direct memory access, it is one of the features of the computer system which enables the data transfer between the peripheral devices and the memory unit of the computer without the intervention of the CPU. Because in those type of techniques, the CPU is wasting its time performing a data transfer, which is not one of the most important function of a CPU. The main function of a CPU is executing the user programs or the particular instructions of a program. So, but in case of a data transfer, the intervention of a CPU is not required actually. So, in case of a direct memory access, we are going to perform a data transfer between the memory unit of a computer and the peripheral devices without the intervention of the CPU. So, here the interface unit of a corresponding peripheral device, it transfers the data into and out of the memory unit through with the help of the memory bus, and the transfer of data between a fast storage device such as your magnetic disk and the memory, if you consider, it is limited by the speed of the CPU. So there are certain speed differences that exist between the different types of devices. So for this reason, we are removing the CPU from the path and letting the peripheral device directly manage the memory unit of the computer so that you can improve the speed of transfer between them. So this technique is called as a direct memory access technique or direct memory access. DMA transfer, the CPU will be idle. So whenever a data has to be transferred between the memory unit of a computer and the peripheral device, the control of the bus is given to the DMA. So during that time, the CPU will be idle and it doesn't have a control of the memory bus because it is being given to the DMA. So DMA contains a controller called as a DMA controller. So a DMA controller takes over the buses to manage the transfer of data between the input output device and the memory. In this type of situation, the CPU will be placed in an idle state. And there are different ways in which you can place the CPU in an idle state. One method is to disable the bus by means of a special control signals. So here there are two types of a control signals called bus request signal and bus grant signal. So bus request signal is represented by BR and bus grant signal is represented by BG. So these two control signals in the CPU that facilitates the DMA transfer. These are the two signals which are mainly responsible in DMA, direct memory access, to transfer the information to and from the memory unit of a computer and peripheral device. The bus request signal. So the bus request input, it is used by the DMA controller to request the CPU. So whenever there is an information that has to be transferred from peripheral device to the memory unit, suppose, at that case the DMA controller will request the grant of the bus to the CPU. It will send a bus request signal saying that I want to access the bus in order to transfer the information over the bus from the corresponding peripheral device to the memory unit. So I want to access a particular bus. Give me a bus grant request. The particular request will be sent to the CPU by the DMA controller with the help of a signal called bus request signal. So when this input is active, The CPU will terminate so whenever the CPU receives this particular signal, it will terminate the execution of a current instruction, and it will place the address bus, data bus, and read write lines. As you know, the IO bus consists of address line, data line, and read write lines. All these lines will be placed into a high impedance state. So high impedance state means that the output is disconnected. The CPU is no longer going to access that particular IO bus. And once it puts the particular bus into a high impedance state, the CPU will activate the bus grant signal and it informs the DMA that it can now take the control of the bus to perform the data transfer between the memory and the peripherals without the intervention of the CPU. And whenever this DMA gains the bus grant, it will complete the transfer. And when the DMA completes the transfer of information, it will again disable the bus request line. So it will enable the bus request line when it is requesting for the bus. And once it gets the grant from the CPU by means of a bus grant enabled, and it will perform the transfer operation of the data. And once it is done with the transfer, it will disable the bus request. So whenever the DMA disables the bus request, the CPU will disable the bus grant signal and it will take the control of the bus and it will return to its normal operation. So this is how a direct memory access works. So the DMA controller needs the circuits of an interface in order to communicate with the CPU as well as the IO devices. And the DMA controller, the direct memory access contains a controller called a DMA controller. Here this DMA controller mainly contains three registers. One is the address register, one is the word count register, and the third one is the control register. So the address register contains an address to specify the desired location in the memory. So for each word that is transferred, the DMA increments the address register and decrements the word count register. So whatever transfer it is taking place, say for example, transferring a word from the peripheral device into the memory. So it for each and every word, the address register will be incremented by one, so that it moves to the next address to store the next word. And similarly, the word count register will be decremented by one. So say if it has to perform three words. So once one word is written into a particular memory, the number of word count register will be decremented by one. So this is a block diagram of a DMA controller where it contains three registers: address register, data register, and data count register. And apart from that, we also have a control logic to perform a working of a DMA, and it contains DMA request and acknowledgement lines, interrupt, read, write, and data lines. We'll see in detail about this during when we see the working of your DMA controller. So now coming to the working of a DMA controller. So the DMA controller has to share the IO bus with the processor to make the data transfer. Processor in the sense CPU here. So the device that holds the bus at a given time is called as a bus master. So whichever device is having the bus with it, it is holding the bus, that is said to be called as a bus master. So initially the bus master is going to be the processor of the CPU. Whenever the DMA wants to access a bus, it will get a access to the bus with the help of a bus grant signal. And at that time, when a DMA is holding the bus, it is called as a bus master. So it has overall control of the bus. So when a transfer from input output device to the memory or memory to the input output device has to be made, then the processor or the CPU, it will stop the execution of a current program, and what it does is it will increment the program counter, and in the next address in the memory it will store that particular information whatever has happened till there into a particular location of the memory or a stack, and then it sends a DMA select signal to the DMA controller. So over the address bus. Told the DMA controller is free, it will request the control of the bus from the processor by raising the bus request signal. And processor will grant the bus to the particular DMA controller by raising the bus grant signal. So the now DMA controller will become the bus master. The processor will initiate the DMA controller by sending the memory address number of blocks of data to be transferred, and the direction of data transfer. So here the communication, the entire data transfer will be take place between the DMA controller and the peripheral device. The CPU or the processor is no longer responsible for the data transfer. The processor is mainly going to initiate the data transfer. It is going to initiate the DMA controller by specifying certain information to the DMA controller by giving some input to the DMA controller, like in which memory address the particular operation has to take place, how many number of blocks of data that has to be read or written, and what is the type of data transfer that has to take place. All this will be intimated by the C processor to the DMA controller, but the DMA controller will take the whole and sole responsibility of performing the data transfer. So after assigning the data transfer task to the DMA controller, instead of waiting idly, so the CPU, instead of waiting and until the data transfer is completed, the processor or the CPU will resume the task. So it has stopped with the execution of the current program and it has stored the data in the stack. Now it will continue with its execution. The processor resumes the execution of the program after retrieving the information from the stack. So the DMA controller now it has a full control of the bus, and now it can interact directly with the memory unit and the input output devices without the intervention of the CPU. So it makes the data transfer according to the control instructions which are received from the processor. So the processors have already instructed the DMA controller what to do. Now it is the responsibility of the DMA controller to perform the task without the intervention of the CPU. So once the data completion is done, it will disable the bus request signal, and the CPU automatically it will disable the bus grant signal, thereby moving the control of the bus to the CPU. So this is the working of a DMA controller. So here we have a CPU, a random access memory, input output peripheral, and the DMA controller, direct memory access, which contains a DMA controller. So whenever an IO device or a peripheral device has any information that it wants to perform a write operation, say it wants to write some data into the memory. So in that case, normally what happens initially is the IO peripheral device, it will send a DMA request signal to the DMA controller. So saying that I want to perform a transfer of information. So I want to so it will send a signal to the DMA controller. So whenever the DMA controller receives a DMA request, depending upon the its condition, like depending on the status of the particular DMA controller, if it is free, it will send a DMA acknowledgement signal. So if it receives the peripheral device receives a DMA acknowledgement signal, it means that the DMA is ready to perform the data transfer. So once it receives a request and once it sends an acknowledgement to the corresponding peripheral device, the DMA controller now it needs to gain access of the bus. So this is an IO bus which contains read write controls, address bus, data bus. So now actually this particular IO bus is in the control of the CPU. So whenever the DMA controller wants to gain an control of this particular bus to transfer the data from the peripheral device to the memory unit of a computer, what it do is it will first send a signal called bus request signal. This is the bus request signal which is sent from the DMA controller to the CPU. So whenever a CPU receives a bus request signal, responds to the bus request signal with a with a signal called as a bus grant signal. So whenever this DMA controller receives the bus grant signal, whenever this bus grant signal is enabled by the CPU, so the DMA will now get an access to the bus. So now it can perform a data transfer. So now the CPU is no longer accessing this particular bus. The DMA controller is has a whole and sole responsibility of this particular bus. So it will perform whether it is a write read operation or a write operation that will be specified by the read and write controls, and the address on which the particular read or write operation has to be performed in the memory unit is specified on the address bus, and the data will be placed by the peripheral device onto the data bus from the this data bus, it will be transferred to the corresponding memory unit of the computer. So this is how a DMA controller performs an operation. So once the data transfer task is completed, the DMA controller will disable the bus request line so that the CPU will now understand that the data transfer task is completed. Now, so that the CPU will now disable the bus grant line. So, and it will gain the control of this particular bus. So this is how the data transfer takes place between the IO peripheral device and the memory unit of the computer with the help of a DMA controller. So coming to the data transfer in the DMA, it can be done in two modes. One is said to be called as a burst transfer mode and second one is a cycle stealing mode. So in case of a burst transfer mode, a block sequence consisting of number of memory words is transferred in a continuous burst. So burst is nothing but a set of words are transferred at a time between the peripheral device and the memory unit, while the DMA controller is the master of the bus. So no, so at a time once a bus request is being granted to the DMA controller, bus grant, then at a time the DMA controller, with the help of a DMA controller, blocks of data or the words of data will be sent between the memory unit of the computer and the peripheral device. So we call it a burst of data. It will be transferred at a time. So we call it as a burst transfer mode. Coming to a cycle stealing mode, this mode will allow the DMA controller only to transfer one word at a time. So after which it must return the control to of the bus to the CPU. So for each and every request, only one word can be transferred between the memory unit and the peripheral device. So next, coming to the advantages of a direct memory access technique. So one of the key benefits of a direct memory access is that it decreases the CPU participation because the CPU is no longer involved in the data transfer, which is the responsibility of the DMA controller to do so. So by this way, it decreases the CPU overhead and it results in more efficient usage of CPU processing capability. So the CPU is not wasting its time, it is using its time to perform some other task. It is just initiating the transfer, but it is no longer responsible for the actual data transfer. So it reduces the CPU overhead and it increases the performance of your system and faster data transfer. So using this technique, the DMA can transmit the data between the memory and the peripheral devices at a high speed with the help of a hardware. Four is efficient resource utilization. So DMA allows a numerous, there are different, more and more number of peripheral devices which are connected to a DMA. So it allows numerous peripheral devices to access the memory simultaneously without the involvement of the CPU. So this effective utilization of the resources, it guarantees that several devices can run in parallel, decreasing the memory access congestion. So that is the one more advantage of direct memory access. Coming to the disadvantages, the complexity. So it setuping this DMA direct memory access setup itself makes the system more complicated. That is one of the disadvantage. The resource contention. So resource contention may occur in this type of a system with several devices competing for the DMA access. Say there are more and more number of peripheral devices which are trying to access the memory at the same point of time. Then this may create a conflict. So and it may cause delays and which may decrease the efficiency of a data transfer. So that is one more problem. If you want to transfer short amounts of data, then this DMA will be an additional overhead. So if you want to transfer only within the words of data, then for each it is a overhead because we have to issue a grant request signal, grant signal. It has to get the control of the bus. Then only the data transfer takes place. So in that case, the CPU may not be able to function more efficiently in case of a small data transfers. When you go for a high data transfers, then this may be an efficient approach. To implement this direct memory access concept itself, you require complicated programming to implement this. Thank you.